Hello students, my name is Satnam Singh and again I welcome you on this online platform of Sandeepni Gurukul. Students, today we will be talking about one of the very important topic over here, which is quantum number. Yes, this quantum number is one of the very important topic for JEE and NEET. Now what happens in quantum number? See students, this quantum number, it gives you information about what? About electron. Actually it gives you the address of electron. अब ये address of electron क्या होता है? Students, suppose I say I stay in Punjab. Okay, in Punjab where I stay? I stay in Pathankot. Okay, in Pathankot, now our Sandeepni Gurukul is in Pathankot. So I am saying I am in Punjab, I am in Pathankot. In Pathankot we are in Kauntarpur, and in Kauntarpur where am I? Like I am in Sandeepni Gurukul 11th standard class. Okay, so this is my address over here. So likewise I say what is going to be the address of electron. See, electron revolves around the nucleus in some orbit. So that orbit, in which orbital it is present. Okay, in that orbital, whether if I say there is s orbital, okay, so there will be only one orbital, but if I say p orbital, there will be three. Okay, so whether it is present in px, py or pz. Okay, if it is d, there will be 5 orbital where that electron is present. That information is given by what? It is given by quantum number. So there are 4 quantum numbers. So what we have written over here is, we have written quantum numbers gives you information about what? About the address of what? Electron. It gives you information about address of electron. Now to tell the address of electron, 4 quantum numbers are required. One is principal quantum number, which is denoted by n. Then there is azimuthal quantum number, which is denoted by L. There is magnetic quantum number, which is denoted by M, and then there is going to be spin quantum number, which is denoted by S. So students, these are the 4 number which will give you complete information about what? About the position of electron. So what we have defined, we have said that quantum number is a set of 4 numbers, okay, which are used to define an electron completely in an atom. Okay, they will be defining an electron completely in an atom. Now one by one we will be talking about these quantum number. The very first quantum number which we are talking is going to be principal quantum number. Yes, principal quantum number is what? If this is the nucleus, I say this is one orbit or one shell. Okay, then there will be another orbit or another shell. So that shell number, that orbit number, that energy level number is given by what? It is given by principal quantum number. So we say it is denoted by whom? What? It is denoted by small n. It is denoted by small n. And it was proposed by whom? It was proposed by Bohr. So we say it is denoted by n and it was proposed by Bohr. Then you say what information it will give you? Already discussed, it will give you information about what? Where that electron is present, in which orbit, in which shell or which energy level. Now this n can have value from what? 1, 2, 3, 4. Okay, n की value 1 भी हो सकती है, 2 भी हो सकती है, 3 भी हो सकती है, 4 भी हो सकती है. Okay, जो n की value अगर 1 होगी तो उसे हम कहते हैं K shell, अगर 2 होगी तो उसे कहेंगे L shell, 3 होगी तो M shell, then there will be N shell, and like this it will keep on going. N cannot be 0, shell number cannot be 0, you should remember this. Then students, number of subshell in the nth shell. See, suppose I say if n ka value is 1, so subshell will be also what? 1. In the first shell, there will be only what? There will be only one subshell, which is going to be S. Okay, which is going to be S. Then they say how many orbitals will be present? In S, there is only one orbital. Okay, there is going to be what? There is going to be only one orbital. So you say 1 ka square will be what? 1. Okay, so there will be only 1 orbital. Number of electrons, see if there is only 1 orbital, you say 2 into 1 square. So it will be again what? It will be again 2. And then the orbit angular momentum is what? It is given by a formula over here, which is going to be mvr is going to be nh by 2 pi. nh by 2 pi. So students, if we say this n ka value is going to be 2. Okay, so number of subshell will be what? It will be also 2, which is going to be S and P. Now number of orbital in them will be what? See, what is that formula? It is going to be 2, it will be what? It will be n square. Okay, it is going to be what? It is going to be n square. So it will become 2 square. So it will become what? It will become 4. Okay, S ka 1 orbital and P K there are 3 orbital. So see, you can see there are how many? There are how many orbital? You say there are 4 orbital. Okay, then if you want to find out the electron, you will say 2 into n square. N ka value is going to be what? 2. So here it will become what? It will become 2 into 4. That is going to be how many electron? That is going to be 8 electron. If we place electron over here, this is 1, 2. This is 1, 2, 3. Here it is 4, 5, and then it is going to be 6. So you can see it is going to be all how many electron? It is going to be all 8 electrons. So students, this is all about what? Your principal quantum number, which is n, denoted by n, proposed by Bohr. It describes what? It gives information about orbit, shell or energy level. Okay, इसका वैल्यू कैन बी व्हाट 1 2 3 4. इसकी वैल्यू कभी भी 0 नहीं हो सकती. Okay, then number of subshell in the nth shell is what? It is going to be n. Number of orbital is n square. Number of electron is going to be 2n square, and this orbit angular momentum ka formula is going to be mvr is going to be what? It is going to be nh by 2 pi. It is going to be nh by 2 pi. So this is about very first quantum number, which is your principal quantum number. Okay, now let us proceed toward the another quantum number, which is azimuthal quantum number. The first we said there was a nucleus, electrons are revolving around nucleus in some orbit. See, when I say first orbit, in orbit there are some places where electrons are present. See, whole orbit is not containing electron everywhere. There are some places where electrons are present. That place where the electron finding probability is maximum, that is called orbital. And information about orbital is given by which number? It is given by azimuthal quantum number. Okay, so you say it is also known as secondary quantum number or subsidiary quantum number. It is denoted by L, and it was proposed by Summerfield. Okay, it was proposed by Summerfield. It describes what? It describes in the orbit where that electron is present, in which subshell, in which suborbit, or in which sub-energy level. There was energy level, there is sub-energy level inside it. Okay, so its value can be what? What is the formula to find out L? It is going to be what? It is going to be 0 to n minus 1. 0 to n minus 1. Suppose you say the n ka value is going to be what? It is going to be 3. If n ka value is 3, L ka value will be what? It will be 0 to n minus 1. Okay, it will be 0 to, what is the value of n over here? 3. 3 minus 1. So it is going to be 0 to 2. Okay, which is going to be 0, 1, and then there is going to be what? There is going to be 2. Okay, so students, here see L can be 0, 1, 2, 3, 4. If L is 0, you will call that 0 stands for s orbital. Okay, 1 stands for p orbital. 2 stands for d orbital, 3 for f orbital, 4 for g orbital. Okay, so here we will say here the s orbital is present, p orbital is present, and which orbital is present? D orbital is present. Okay, so you see if the energy level is the third energy level, it will contain s orbital, it will contain p orbital, plus it will contain how many orbital? It will contain see one more orbital, which is going to be d orbital. Now students, can you tell me from the previous knowledge that how many electrons? See, if n ka value is 3, number of suborbits are also 3. Number of orbital is what? 3 ka square. So it is 9 orbital. See, here 1 orbital, here 3 orbital. It is going to be 4 orbital, and here there are 5 orbital. So 4 plus 5 is going to be what? It is going to be total 9 orbital. If the orbitals are 9, tell me how many electrons it will contain? It will contain 2n square. That is 2 into 9. It will be having 18 electrons. It will be having how many electrons? It will be having 18 electrons. See students, we have applied all this formula for n ka value what? 3. Students, now what other information is given by azimuthal quantum number? Okay, see, we want to find out maximum number of orbital for a given value of L. And the formula which we are going to, like, see, the formula which will be applying over here is going to be what? It is going to be 2L plus 1. Maximum number of orbital for a given value of what? L. If the L ka value is going to be what? It is going to be 0. So we say, see, if L ka value is going to be 0, so it will be s orbital. S orbital will have what? It will be having only 1 orbital. Okay, so here what we will say, it will be 2 into 0 plus 1. So it will be 0 plus 1. So here there is going to be 1. Okay, what if we take here 1? If we take 1 over here, it will become what? It will become 2 into 1, that is 2. 2 plus 1 will become what? 3. So you know P contain 3, Px, Py and Pz. So students, maximum number of electron in a given value of L, whatever 2L plus 1 you have got, into 2 you will do. Okay, so here maximum number, see, if L is 0, number of orbital will be what? It will be 1. What number of electrons it will contain? It will contain 2 into 1. Okay, so it will be having how many electrons? It will be having 2 electrons. Okay, and then this orbital angular momentum is given by the formula under root L into L plus 1 h by 2 pi. Okay, which is under root L into L plus 1 cut h. Okay, you can call it as what? Cut h. See, what is this cut h over here? It is Bohr's constant, which is going to be h by 2 pi, which is going to be h by 2 pi. So students, in this azimuthal quantum number, we talk about what? We talk about orbital. In principal quantum number, we talk about what? We talk about the shell. And then in azimuthal quantum number, we talk about what? We talk about the subshell. Okay, now here the another case, you say it is going to be what? It is going to be your magnetic quantum number. Okay, magnetic quantum number is denoted by what? It is denoted by M, or you say it is denoted by ML. Okay, and proposed by whom? Proposed by Linde. It describes the orientation of electron. It describes the orientation. Okay, in orbital, in that orbital where the electron is oriented. Okay, if it is p orbital, it may be oriented along x-axis, so it will become px. If it is oriented along y-axis, it will become py. If it is oriented along z-axis, it will become what? It will become pz, students. Okay, so students, what we will say, it describes what? It describes the orientation of electron. And its value is going to be from minus L to plus L. Okay, see, for s orbital, see, this L is going to be what? It is going to be 0. So m ka value is going to be what? It is going to be minus 0 to plus 0, which is finally 0. Okay, so here there is no orientation. It is a spherical orbital. S orbital is going to be what? Spherical, and electrons are present inside it. Okay, now we are going to talk about p orbital. For, you know, for p orbital, L is what? It is 1. तो m का वैल्यू विल बी व्हाट, इट विल बी -1 to +1, -1 to +1. Okay, when I say -1 to +1, so it will be -1, 0 and then +1. Okay, so there is -1, okay, then +1 and then 0. So 0 is going to be what, it is going to be pz. Plus and minus can vary. See here what I have done, I have taken -1, 0 and +1. For 0 I have fixed, it is what, it is py. Okay, for -1 we have written px over here and py over here. Above what I have done, I have taken 0 over here, I have fixed pz. Okay, and for +1 this time I have written what, I have written py, and here we have written what, we have written px. Okay, so plus minus 1 can be px or py, but 0 is what, it is pz. Okay students, for d orbital L ka value is going to be what, it is going to be 2. And then m ka value will be what, it will be -2 to +2. So it will be -2 to +2. Okay, -2 to +2 means what, it will be -2, -1, 0, +1, +2. Okay, it will be -1, -2, -1, 0, +1, +2. Again for 0 you have to fix dz square. Okay, and here for minus or plus, for minus and plus 2, what we can write, we can write either dxy or dxz. Okay, likewise it is for other quantum number. For plus or -1 we can write dyz, or we can say dx square minus y square, but this dz square is going to be fixed, which is going to be 0. Now students, for f orbital, this f orbital, for f orbital L ka value is going to be what, it is going to be 3. So m will be what, it will be -3 to +3. Okay, so we have written over here -3, -2, -1, 0, +1, +2, +3. You can call them as what, f1, here it is f2, here it is f3, here it is f4, here it is f5, here it is f6, and here it is going to be what, it is going to be f7 students. So this is about what, your magnetic quantum number. Now the last quantum number which we are going to talk over here, it is going to be your spin quantum number. Okay, it is going to be which quantum number? It is going to be your spin quantum number. See now, see this orbital students, this orbital, they contain 2 electrons. Okay, if one is moving in clockwise, the other one has to move in what, it has to move in anti-clockwise, then only their spin will get cancelled. Otherwise, if both are moving in clockwise, their energy will increase and they will try to move out. Okay, so one spin should get cancelled by another. तो अगर एक का spin plus, see if it is +1/2, तो दूसरे का क्या होना चाहिए, it will become what, -1/2. We are talking about these 2 electrons which are present in the orbital. So students, you say spin quantum number, it is denoted by S, or you say ms, and it was proposed by Uhlenbeck and Goldsmith. Uhlenbeck and Goldsmith. It describes what? It describes the spin of what? Electron. If one is spinning in this way, another one will be spinning in this way. Okay, like this. So you say S ka value can be what? S is what? Total spin. It will be what? It will be plus minus n/2, plus minus n by 2 over there. What is n over there? N is the number of unpaired electron. It is the number of unpaired electron. Now students, these some formulas which you should remember. Spin angular momentum, initially we have seen with orbit angular momentum. Then we have talked about orbital angular momentum. Now we are talking about spin angular momentum, which is going to be under root s into s plus 1, and then here the out of root you have to write cut h. What is cut h? It is going to be h by 2 pi. Well, how to find out s students? S will be what? It will be n/2. What is n over here? N is again the number of unpaired electron. Now students, one more formula which you are supposed to remember. If they ask you to find out the spin multiplicity, you will be using the formula what? You will be using the formula 2s plus 1. What is s over there? It is n/2. What is n over there? N is the number of unpaired electron. See, they keep on asking questions on these. This magnetic moment is their favorite part. They always ask find the magnetic moment for ion. Okay, so you will be writing the electronic configuration, then you will find the number of unpaired electron, and then you can find out what is the magnetic moment, which is given by under root n into n plus 2 bm. Bm is called Bohr's magneton. It is the unit Bohr's magneton. What is n over here? N is the number of what? It is the number of unpaired electron. So students, in this session we have learnt about what? The 4 quantum number, which is principal, azimuthal, magnetic and spin quantum number. And what these quantum numbers are going to do? They will give you all information about electron, where that electron is present, in which orbit, in that orbit, in which suborbit. Okay, if like see, if you know the suborbit, that is you know the orbital, then what is the orientation of electron in that orbital, and finally it will tell you information about what is the spin of the electron. Either it will be clockwise or it will be what? It will be anti-clockwise. It is like a address of a electron. Okay students, hope you all have understood with the part. Thank you for watching the video.